So we now have our question. When will she have $1,500? This is referring to our previous situation where Dejanique invests $1,000 in an account with an annual interest rate of 10.3%, compounding monthly. And in another video, we set up the equation here. Okay, so we're going to have to use this equation to figure out in how many years will Dejanique have $1,500. Before we continue, we want to make sure we simplify this equation as much as possible just so it's a little bit easier for us to solve later on, okay? So we have this like 1 plus 0.103 over 12. That's kind of messy, like I kind of want to make that one number, okay? So I'm just going to focus inside the parentheses first. So in PEMDAS order, we have a division here and we have an addition. And D comes before A, so we're going to divide first. We're going to do 0.103 divided by 12. And that becomes, I calculated earlier, that becomes 0.00858. So if we add a 1 here, this whole thing becomes 1.00858. Okay, I'm going to bring everything else down. Okay, so the inside parentheses become 1.00858. And this will be a little bit simpler for us because it's one number instead of all this stuff. So when will Dejanique have $1,500? Well, we're going to use this equation, and we have a dollar amount here. Okay, so we're going to have to plug in this dollar amount in either the X or the Y. And in previous problems, we learned that the X is how many years passes, and the Y is how much money you will have after those X years. So since we have the money, we're going to put that in the Y. Okay, so I'm going to rewrite this equation up here, except the 1,500 will go in the Y. So 1,500 equals 1,000 times 1.0058 to the 12x. Okay, so we have this. And now we want to solve for x. And notice how the x is in the exponent. That's going to be really hard to solve for x. We want to bring that exponent down. So how are we going to do it? We're going to use our logarithmic form. When we have an exponent here and we want to bring it down, we can rearrange this stuff so that the exponent is no longer stuck up on top of some other number. Okay? So this is the goal, to get to here. Okay, we want a base, value, and exponent. So I can look at my thing and be like, my equation, and be like, okay, the 1,500 is my value, and the 12x is my exponent, and then my base, is 1.0058. But this 1,000, like, where is this 1,000 supposed to go? Okay, that does not fit in this form. So we want to actually get rid of the 1,000. And actually earlier I said 1,500 is the value. I shouldn't have said that. That was actually incorrect. So we want to get rid of this 1,000. Okay? So I want to divide it out. I want to bring it to the other side. I'm going to divide 1,000 on the right. I'm going to divide 1,000 on the left. This cancels. And 1,500 divided by 1,000 is 1.5. Okay? That equals 1.00858 to the 12x. Okay, so now we have a base, value, and exponent. This is my base, the 1.00858, because it's under the exponent. The exponent is 12x because it's on top. And the 1.5 is the value. So now I'm going to rearrange my number so it looks like a logarithm. So we have log base, that's an ugly base, but it's okay. It's 1.00858. What is the value? The value is this 1.5 of 1.5 equals the exponent, 12x. And now look, the x is no longer stuck on top of a number. It equals 12x. Okay? But now we have this ugly logarithm. It has this ugly base, and when you're using a graphing calculator, especially in AP Calculus, your graphing calculator might not be able to handle this. So what we're going to use is we're going to use the change of base formula, where I can make any logarithm with whatever base into a fraction where the bases are the same, where the base is 10. So instead of log base this of this value, I'm going to rearrange it so it looks like this fraction. So now it's going to be the log of the value 1.5 over the log of 1.00858, and that equals 12x. Okay, I'm running out of space. I'm going to erase this stuff and continue over here. All right, so now I'm going to, this thing I'm actually going to rewrite up here. Log of 1.5 over log of 1.00858. That equals 12x. If I punch this in my graphing calculator, log of this over log of this, I get, what do I get? I get 47.498. If I punch this in my graphing calculator, okay? And now I want to solve for x, so I have to divide 12 on each side. And x is going to equal 3.955 years. And we're done.